Hi everyone, my name is Abel Gray Kantoma. I'm from GREYTEST CAD Design Concept. This is actually my WhatsApp contact. You can reach me on this number or you can call me, okay? These are the list of softwares which I've covered on our YouTube channel. They are very much available on that channel. Visit the link to that channel down below the description of this video. You find a link to that channel. Visit and keep yourself busy, okay? We have covered architectural drawings, structural designs, and mechanical designs and electrical service drawings. We've covered water designs and road designs, okay? They are very much available on that channel. We now teach all of these softwares on our Telegram platform, or we'll give you the software, we'll guide you on how to install it and how to crack it on your system just for a token, okay? I will train you for 40 days, okay? Today I'll be taking you through a 3D plane of a frame design, okay, on Staadpro. Okay, I have covered a plane, a single plane. I've covered 2 planes on a frame, and today I'm going to be showing you a 3D plane on your Staadpro. Okay, we are going to be modeling it and then we'll analyze it, okay, and then as well design it. Okay, let's jump right into it now. Firstly, you must configure just like we did in the previous episode. This episode is actually the episode 4 of this training on Staadpro. Okay, episode 1, 2, 3 are very much available on that channel, on this channel as well. So after doing your configuration, this is where you actually set your code of practice and then the units of measurement and force that you actually want to use. Okay, I'm going to click on new project and I'll check on this, and then I'm going to name this 3D frame. Okay, then I'm going to leave this as it is, and then I'll click on next. Yes, I will overwrite this, and now I'm going to click on finish. Now this is actually the window. You can design from here as well, but on this tutorial I'm not just going to focus on this. I'll close this. I'm going to be doing my design from this point. This is a diagram that we are considering today. You can see the width from this leg to this leg is 4 meters, from here to here is 5 meters, and the height is actually 3 meters. Okay, we have, these are the columns and this is actually the beam. We may not be considering the slab on this tutorial, but on our next tutorial I'm going to be taking you into that slab design on Staadpro. So I'll be taking you through this column design using a fixed support. Okay, you can see all the support here are actually fixed. This side, this is actually going to be our origin, so starting from this point. So if that is correct, let's jump right into it. So this is 0 and I click on enter. Now if you look at this, the distance from here to here is actually 4 meters. Okay, so I can just highlight on this. Okay, make sure you always turn on this note cursor in order for you to highlight your notes. Okay, and then I'll copy and then I'm going to paste. I'm pasting it in a y direction, just like as I have explained in previous tutorials. When you are going in this direction, you are going positive. When you are coming this direction, you are going negative. Now if that is correct, so I'm going to make this 4 meters. 4 meters, yes. So I'll type in 4 meters and I'm going to click on OK. Now you can see we have different planes on views on Staadpro, which I have explained in my previous tutorial on Staadpro. So I'm going to make this on Z view, and then to take this actually up. So after having this, if you look at this, this is actually in a Z direction. As you can see, we are viewing from this. Okay, this is actually in a Z direction. So to achieve this, okay, there are different ways I can actually use to achieve this on the Staadpro software. So all I'm going to do right now, I can just highlight on all of this, and then I'm going to actually copy, and then I'm going to paste. Now since this is actually in a Z direction of how many meters, let me confirm, 5 meters, so I'm going to type in 5 here. Okay, then I'm going to click on OK. Okay, but we can't view it until we come here. You can see, good. So this is what we have right now, and then the next thing I'm going to do is to highlight all of these, and then I'm actually going to take it up. Now I'm going to right click, I'll copy, and then I'm going to paste this note. Now this is actually in a height of let me confirm, 3 meters, so I'm going to paste it at 3 meters. Okay, now good, this is what we have. Okay, so the next thing I will do is to go to my add beams, then I'm going to draw all of my points here. Sorry about that. I think this is wrong. Yes. Sorry about that. Okay, just a bit confusing. Okay, now good. Now I can actually confirm the dimensions of this structural element. All I need to do is just to come to my dimension, and then I will check on display, and I click on display. Now you can see the height is 3 meters, distance from here is 5 meters, from here to here is 4 meters. Okay, good, which is actually okay. I'm going to remove, and I click on remove, and I will close this. Now I have all of my nodes and I have all of my beam. The next thing I'm going to do is actually to create a section for this. Okay, and then to do that I will just have to come to my general. Okay, you can see the section view menu has actually popped up. So what I'm going to do is to click on my define. When I click on define, I'm going to use a rectangular section for both my columns and my slab, my column and my beam rather. Okay, so for my column I'm going to be using a 230 by 230, so 0.23 is the same thing as 0.23. I hope you know that. Okay, this is actually my column, so I'm going to add that. Okay, you can see it added here, and then my beam is actually going to be 0.45. Okay, and then I'm going to 0.45 by 230. Okay, good. Now I have my sections for this. Now my columns are going to be okay, sorry, let me turn on my notes. Notes point, apply, click on OK. Come on, play. Okay. Okay, let me come on plan view. Wow, share. Come on bottom. Okay, everything is perfect. So I'm actually going to be specifying this size of to my column. So all I need to do is just to go under select, and I'll come to parallel X. Okay, I can switch this to 3D so you can see. Okay, parallel X. So sorry, for beam I'll come to select, and then I come to parallel X, and I'm going to assign to selected beam. I'll click on assign, I click on yes. So I go to select again, and then I will choose on parallel X for Y. You can see this is actually selected. Okay, and then I will assign. Okay, good. So I'll go back to my select, and I'll come to my parallel, and then beam. Now Y is going to select all of my columns. Okay, you can see 2 3 4 5 2 3 5 6. Okay, have been selected. So I'm sorry, now I will switch it to column. Okay, so you have to be very careful with this, so as not to, I'm just trying to speed this up. Okay, so I will assign, and then I click on yes. Now all of my section has been assigned to all of my structural members. Okay, good. Now after assigning all of this section to all of this my structural member, so I'm going to support. Okay, so I'll go to support, I click on support, and then I'm going to actually create a support. So if you can remember, I said all of my supports are going to be fixed, so I'm going to make that fixed, and I'm going to add, and then I'll click on this support. I can switch this view this way, and then I can just highlight this, assign to selected nodes, and then when I assign this, it will assign to all of my supports. Good, you can see all of my support have that's a fixed support. All of my columns rather have those fixed support on it. So let me switch this and see. Sorry, I think there is one that is missing, so I'm going to assign, yes. Okay, so let me come to isometric. It's like there is a node here that is actually missing. So good, I can actually take off this support. I can delete it. Okay, so I just deleted all of this. So this particular node, I can actually select this, and then I will copy this, and then I will paste these nodes, and then I'm going to make it at the height of 3 meters. Okay, so I'll make it 3. I click on okay, sorry, I'll come here, select this, and then I can delete this. Yes, I'll select on these nodes, I'll copy, and I'll paste these nodes. I'll make it -3. Okay, it's actually supposed to go down. Good. Now I'm going to draw this beam to it. I'll drag here, and I'll draw. Okay, so I'll go back to my general here. section. Okay. I can assign. Okay. Let's come back to good. Come back to my general. I'm going to this section. I'm going to select on this, and I'm going to assign this, and I'll click on yes. Good. I'll come back to my support, and then I'm going to create support, fix support, and I'll add, and then I can switch this view. I'll highlight this, and then already my support, I've selected that. Okay, so I will assign this, and I click on yes. So let's view this now. Good. You can see all my columns has those supports right now. So the next thing, after having my section added to my structural members, having my supports to my structural members, okay, I can actually go down to these symbols and check for my beam numbers, and then my nodes, and then I apply, and I click on OK. You can see everything is actually showing up here. Okay, I'll go to my load and my definition. Okay, so after this, and I'll go to my load and my definition. I have different load cases here. Click on yes. So I have load cases here. I'm going to add, so I'll add my dead load. I'll name it dead. Okay, so I'll now add my live load. I'll name it live. Now on my dead load, okay, I have the self weight, which I'm actually going to add to that, and then on these beams I'm going to be adding some loads like the wall load on it. Okay, so I'm going to be adding that right now on my beams. Okay, so if we come down here, let's say we are having load on this and this. If I come here, if I have this and this, I'm going to make it at 11 kilonewton per meter. This I'm going to make it 15 kilonewton per meter. Okay, this is just an assumed value. Further, when we further into these tutorials, I'm going to be using a practical load where we are going to be calculating that using our live load, but today I'm going to be using an assumed value of 15 and kilo, and then 11. Okay, so if you go down, if I go down now to my dead load, and then I'm going to click on add. Firstly, I'm going to have my self weight on this. Okay, so my self weight, I'll click on add. Okay, so now I have my self weight attached to this, and then the next thing I'm going to do is to actually have this other load, like the wall load from this. Okay, if you like what you're seeing, make sure you like this video, give it a thumbs up, subscribe to this channel. It's actually free. Click on the bell icon so as to always get a notification whenever I post videos, I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Okay, so on my member load, if I come to my member load, so I'm going to be having a wall of the load. This I'm going to make it minus 11 kilonewton, and then I'm going to leave this at 000 because I'm assuming this to be a uniformly distributed load. It is actually uniform across that particular beam, so I'm going to leave it at gy global y. Okay, so I will add this. I'll come down and add another 15. Okay, and then I'll leave it all at 0 and I'll add. Okay, so the next thing I'm going to do is to actually add for that of the floor. Okay, so all I'll need to do is to go to my floor load. Okay, minus 1. Okay, I'm going to be having now, you know, ordinarily when you have your loadings actually come from your slab actually distributed down to your beams takes it down to your column. So on the slab we are going to be assuming like your floor finishes, okay, and all that. We're going to be considering that here. So I'm just going to be using a value of I'm going to leave it as -1 here. Then I'm going to be explaining this particular part where you have your defined range, define y range, and your define x range, okay, and define z range. Okay, so we have different range, assuming we have different floors. For example, where you have a floor like this, let's say we have a floor, okay, and then at different levels, okay, like this, and like this. And then let's say each floor is actually 3 meters. Okay, now at this level is actually 3 meters, for example. At this level is another 3 meters. So if you sum from here to here, actually gives you this is 6 meters, right? And then the next one is going to be 9 meters, if that is correct. Now so from this 0 to this point, okay, is actually your y range. Okay, so your y range can actually fall at a point here where you may have maybe, let's say, 1.5, and then the highest point at this is actually 3 meters. When you exceed these, your y range can still exceed this to a level, and then but once you get to this point of 6, this is actually another different range. Okay, so if you are dealing with just this first floor, which is this first suspended floor, your range is actually going to be anything from here now to this point. Okay, so let's go back here, and then our y range, the minimum can be anything within this range. Like I told you, if I'm only going to be dealing with this floor, for example, anything from 0, maybe you get to 1, and then you get to 2, 2.5, and up to this height. Now my range, the minimum range, I can decide to pick any value, either 0.5, 1, 2, 1, 2.5, 2.2, or any value. Okay, and then my maximum range cannot be up to 6 because this is the floor I'm actually dealing with. I'm considering this particular floor, so I cannot get up to 6. But anything less than 6, but definitely not below the value of 3 can be my maximum. So my maximum is going to be anything from 3 upward, but definitely not up to 6 meters. If you understand that, so I'm going to make my minimum range here to be let's say 2, and then my maximum is actually going to be 3, because that is actually the height of my. But to confirm this, let me just check the height. Okay, good. Now the height is actually 3 meters, so I'm going to assign these, and then my x range. Okay, my x range is actually the width of that particular panel. So let's assume that I'm having a panel, okay, like this. Okay, and then I have we have a panel and then we have another panel that goes like this. So let's say we have our panel 1, we have panel 1, panel 2, panel 3, panel 4. Okay, so if this is actually my P1, for example, this is P2, P3, P4. Okay, so assuming that from here to this point is let's say here we have 1 meter here, 2 meters here, and this is 3 meters if you measure, for example, from here to here. And then at this point here it's actually 1 meter, this is actually 2 meters, and then this is 3 meters. Okay, good. So my y range, for example, if I'm only considering this particular panel, just this panel alone, okay, if I'm considering just this particular panel here, now if this is just the panel I'm actually considering, my y range is actually going to be my minimum. Okay, now you can see this is actually x. Okay, and then you know, we have our x, we have our y, and then we have our z. Okay, so this is actually from here to here is actually 2 meters. Okay, so and then let's take this again and say here we have another 2 meters from here, for example, if actually everything is going to be squared. Okay, so my range here, if I specify the value of saying let's say I have these here, if at x, okay, let me just make this briefly. Okay, so after doing this explanation, just in case you have for any more challenges, you can actually just let me know. Okay, so that I can explain further. Okay, so if you have your from here, you can see we have x range, we have y range, which we just considered, we have our x range, okay, and then we have our z range. Okay, so this, I'm even supposed to make this this way, so that it will be more explanatory this way. So you have it on a plane like this. Okay, so definitely at this point you are going to have your z here, and then this is actually your x here. You know, this is at an angle, so it's actually at x. Okay, this is at z, this is actually our x. So if you are standing at a point like this, you are viewing it at a Z. Okay, now this is actually our X. Now if that is correct, now if you are viewing this from X plane, you're going to be having, for example, if we are considering just this particular panel, so if you have from the range of 1, for example, to 2, okay, for your X, and then if you come here for your Z, let's see, for Z we have Z, and then we have 1 to 2 as well. Now this is the panel you are actually talking about. Okay, what in a case where we have our range to be at X is actually let's say we have 2 here, and then we have 3 here. Okay, for X we have 2, we have 3, but for my Z is actually 1, 2. Okay, you can see it's still at this direction for Z. Okay, just in case if I actually divide this into 4, let's assume this actually is what we have here. Okay, if this panel is the same thing as what we have here, now you viewing it from Z, okay, at Z is still at this point. Okay, so at Z is 1 to 2, and then at X, this is the panel we are actually talking about. We are talking about panel 2. Okay, I hope you understand that. Okay, now let's go back into this right now. But since our design right now is actually just a single panel, so there may be no need for entering the value for X and Z. But just in a case where you may have different numbers of panels, that is how to actually achieve that. So and then we are not considering a one-way distribution. Okay, it's actually going to be a two-way. Okay, so if that is correct, all I'm going to do right now is just to click on add. Now now after doing this, we'll go down into that of our live load. So I'm going to click on add. Now mind you, it's actually on global Y. Okay, so I'll click on add. Okay, so if you like this video, make sure you like this, give it a thumbs up. Okay, give it a thumbs up, subscribe to this channel, is 100% free. Okay, now you can see all of our loads here have question mark, except this, that of a floor, which is showing us to which is giving us this the one for this floor, that is for the slab, is actually showing us there's no question mark here, but this is showing us there is a question mark. The reason is because our load has actually been all of this has not been assigned to these members. Okay, but this automatically will just be assigned automatically. It would assign to the structural member automatically. Okay, but this will have to assign them to these members. Okay, so when you go on that this live, so we are going to live load, and then I'll click on add. If I go under my floor load, right now I'm going to have this to be -2. Okay, under my pressure, just like the way I explained initially. Okay, so this is actually going to be at the range of let's say minimum of 2, and then my maximum is actually going to be 3. Okay, remember we just have one suspended floor. Okay, so so I'm going to, okay, this is for my Y range, this is for my X range, so I'll click on add. Okay, and then I'll close this. Okay, so I'll close. Now you can see that this actually is still not showing us a question mark here. Okay, we are still not having a question mark on this. But in a case, you can see whereby this your load is not actually positioned the way you want it, you can actually just double click on it and it will pop up again, and you can do all of that readjustment there. Okay, and then close. Now you can see by just clicking on these ones, you can see the load life load has been subjected to this structural member automatically. So if I click on this, you can see this is the load. You can see the wall load on the beams. Okay, you can see all of that here. Okay, if I switch this now to my plan view, you can see what we have here. Okay, so the next thing I'm going to do is to actually assign my self weights to all of these. Now let me come here to 3D, and then I click on self weights, and I'll just highlight on all of these, and then I'll assign to view. Okay, so it's going to assign to everything there, and then I'll assign. Okay, so this is actually the self weight of the building itself. Okay, coming to this now, all I will need to do is to I'll come to my select, come to my parallel X. Okay, you can see it has selected this beam and this beam, because I want to make this at 11 minus 11 kilonewton per meter for the wall load that is actually going to be there. So I'll assign to selected beam, and then I'm going to assign, and I'll click on yes. Now you can see the load added there. Now if I go on to select, I come to parallel and I make it Z. You can see it has selected these two beams, and then this is the load I want to add to that. Okay, go to parallel Z. Sorry about that. Come to select, parallel Z. I'm going to assign to selected beam, and I'm going to assign, and I'll click on yes. Now you can see all of my load has been assigned to all of that. Okay, so my self weight, you can see there is no more question mark on any of this loading right now. Okay, so the next thing we are going to do is to go down to our analysis, and then our analysis and print. If I click on analysis, I actually don't want to view any of this, but any load I want, whatever value I want to see from my design, I can just click on it, and then it's actually going to display for me. So if I click on add and I close this, and then the next thing I will do is to go down to analyze. I'm going to analyze this building. Click on save, yes. So it's actually analyzing this for me right now. Now I'm going to view output file. Let's view this and see what we have. Okay. Okay, good. Okay, close this. The next thing I will do here is just to come to my design. You can see I just clicked on my design, and then on my design I'm going to select the parameters. Okay, now you can see I have different parameters here. I'm going to be defining some of them here. Okay, so all I will need to do is to, you can see all of these parameters are selected. That means I'll have to impute all of these parameters for this, but I'm going to select some. I'm not going to be imputing all of them. So I'll come up here and check for the grade of concrete. Okay, I can go for a grade of concrete. Let's see for as these compression members with moments. I come here. Okay. Use steel. Okay. I'm going to design for this grade of concrete. Then select parameters. Okay. Select previously, select section, compression. Okay, I'm going to leave this. Then I'm going to define those members I just actually now you can see the grade of concrete. We have 10 Newton per millimeter. I can select any of this grade of concrete. So once I select any of these, I can just add that. If I come down to my characteristics yield of steel, okay, I'm going to be imputing that value. I want to use 460, okay, and then the 460 is going to be in Newton per millimeter square. So how to convert that, I can just go down to my converter here. If I come down to my tool, okay, come to tool, I come to unit converter, and then I have stress, and then stress or pressure. Okay, good. Now I'm converting Newton per Newton per millimeter. So I'll come here to my Newton millimeter. You can see Newton per millimeter. So I'll make this meter, I'll make this kilonewton. So these are the value I'm converting. My input is Newton per millimeter square. My output is going to be kilonewton per meter square. So I'm going to type 460. Now you can see this is the value we have. So 460000. So good. So we are going to have 460000. Good. So I'll go back to my define, and then I'm going to define this. I'll make this 46000. Good. So I'm going to add this, and then I'm going to close. Now you can see that my characteristic strength of concrete, okay, has been added, and then my main, that is my strength of characteristic strength of my concrete and my steel. This is for my steel, this is actually for my concrete. Now after doing that, the next thing I'm going to do is to click on my commands. Okay, so for my commands, I may decide to add member take off. I can add take off. Okay, let's say I'm going to add my take off, and then I'm going to add my member take off as well. Okay, so I'll close that. Okay, good. Now I have all of this. Now you can see that my main characteristic strength of concrete and steel, you can see that is actually still showing me this question mark. So to do this, I can just come to my select. I'm going to select or instead I can just highlight all of these, and then already this is selected. I can just assign to view, and I'm going to assign all of this to my view. Okay, I can come to my steel here, and then this is the steel I'm going to be assigning to all of these. Assign to view, and I'm going to assign to all my view. You can see the question mark has gone, and then my take off as well. I highlight on take off, assign to view, or assign all to view, and then my steel I'm going to assign to view. I'll highlight all, assign to view, and I'll assign, and I'll click on yes. Now you can see everything has gone off. Now there are a whole lot of things you can add. You can add your concrete cover, you can specify so many other values to this. Now you can see the reason why some of those parameters did not come up for us. You can see this is actually BS5400. okay, so you this will actually affect whatever parameters that comes up for you. Okay, so what if I change this to BS sorry, let me look for that. You can switch that here from here. BS, sorry, let me take this gradually up, and see. Oh, it's supposed to be here, there. So we have different code of practice here that you can actually select from. Okay, so your code of practice will determine the parameters that you see. Okay. Okay. Some code, I can't find some of those code here. BSK99. Okay. No problem. I'm going to let's check these parameters here. So you can see the parameters here has actually changed. Okay, you can see the available parameters, everything here has actually changed, different from the previous one. So whichever code of practice you actually select will determine the parameters that will actually come up for you. Okay, so but I'm just going to leave this as it is. On our next video, I'll be taking you through proper on how to assign all of these because we are going to be considering some live designs on this. Okay, so I'm going to leave this as it is, and then I will go down to my analysis again. I'm going to reanalyze this. I'll run the analysis. If I go down to my view output and I click on done, now you can see down here I have my results. Okay, so if I click on my results, okay, you can see this is actually my takeoff. Okay. Okay, good. Okay, so from here I can just view all of my share, my displacement, my movements. I can check for all of this. You can see my bending moment, and then my shear force is actually showing. I just turned that off. This is actually my moment, so you can view your moment at the beam, and then at even your support as well. Okay, and then if I go down here to my okay, let me go down to post processing, my live loop, and then I apply this and I click on OK. Now you can see my post processing. Normally once you have an error from your analysis, you will not be able to come to your post processing. Okay, you will not be able to come to your post processing. So I can actually go down to my results and come down to my view value. I come down here. So at bending moment at maximum, if I annotate this, you can see the bending moment at maximum. You can view for the bending moment at the midpoint. You can check for the shear force, and then I take this off actually for this. It's because now my shear force now is turned on. Click on maximum, you can see it has come up. I can click for the midpoint. If I annotate, you can see I can take off my moments. You can see this is just the shear force that we have. If you love what you're seeing, make sure you like this video, give it a thumbs up, subscribe to this channel, is 100% free. Click on the bell icon so as to always get notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, so as to encourage as many that wants to have a deeper insight of design. Make sure you stay safe and make sure that you stay